Imagine powering a spacecraft without solar panels, without fuel refills, for decades. And the crazy part? NASA is using an engine invented over 200 years ago. An engine so silent, so efficient, that it can survive the freezing darkness of deep space. This is the Stirling Engine. At first glance, it looks simple. No explosions, no roaring combustion, no giant turbines, just heat, cold, and a moving piston. But somehow, this old machine became one of NASA's most reliable space technologies. In fact, some deep space missions would be impossible without it. So why is a Victorian-era engine still powering futuristic spacecraft? The Stirling engine was invented back in 1816, long before airplanes, rockets, or modern electricity even existed. At that time, most machines were powered by dangerous steam engines that could explode under pressure. Engineers needed something safer, smoother, and more reliable. That's when a Scottish inventor named Robert Stirling created a completely different type of engine. Unlike normal engines, the Stirling engine doesn't use explosions inside the machine. Instead, it works using temperature difference. One side becomes hot, the other side stays cold, and the gas trapped inside constantly expands and contracts. That movement pushes pistons back and forth, creating smooth rotational power. W equals integral PDV, and compared to normal engines, this thing is incredibly quiet. Car engines explode thousands of times every minute. Rocket engines create violent combustion powerful enough to shake buildings. But the Stirling engine moves almost silently, with very little vibration. That's exactly why NASA became interested in it, because in deep space, reliability matters more than speed. A spacecraft millions of miles away cannot stop for repairs. If a system fails, the entire mission could be lost forever. NASA needed something capable of running for years without breaking down, and the Stirling engine was perfect for that job. Fewer explosions means less stress on parts. Less vibration means less damage over time. Some experimental Stirling systems have even operated continuously for years with minimal wear. Another huge advantage is efficiency. Most engines waste enormous amounts of energy as heat, but the Stirling engine was literally designed to turn heat into useful power. And in space, where every bit of energy matters, that efficiency becomes incredibly valuable. But here's where things become even crazier. NASA doesn't heat these engines using gasoline or even solar panels. Instead, they use radioactive decay. Deep space is extremely dark and cold. Once spacecraft travel far away from the sun, solar panels become much less effective. Missions going toward distant planets still need electricity for communication systems, scientific instruments, computers, and heating systems. So NASA uses special radioactive materials that naturally produce heat for decades. That heat never stops. Day after day, year after year, the material continuously releases thermal energy. And instead of wasting that heat, NASA feeds it directly into a Stirling engine. The engine converts thermal energy into electricity with incredible efficiency. This system is called a radioisotope Stirling generator. Compared to older space power systems, it can generate much more electricity while using less radioactive fuel. That means spacecraft become lighter, missions last longer, and more power becomes available for scientific equipment. NASA engineers tested some Stirling systems continuously for years without major failure. Imagine a machine running non-stop for years in the freezing vacuum of space, millions of miles away from Earth. And because the engine runs so smoothly, vibration stays very low. That's important because sensitive scientific instruments can be affected even by tiny movements. The farther humans travel into deep space, the more valuable systems like this become. And somehow, one of the best solutions came from an engine invented over 200 years ago. But the Stirling engine isn't only useful in space. The same technology can work almost anywhere, as long as there's a heat difference. Most engines depend on very specific fuels. Cars need gasoline, jets need aviation fuel, rockets require carefully controlled combustion. But the Stirling engine doesn't care where the heat comes from. Fire, solar energy, geothermal heat, hot metal, even the warmth from a human hand can power small versions of it. That flexibility makes the engine incredibly unique. Engineers have experimented with Stirling systems powered by sunlight in deserts, underground geothermal heat, and even waste heat from factories. And that's important because modern machines waste huge amounts of energy as heat. But the Stirling engine was specifically designed to capture thermal energy and turn it back into useful work. That's why engineers still study this technology today for submarines, renewable energy systems, and even future space colonies. And maybe that's what makes the Stirling engine so fascinating. It proves that sometimes the smartest technology isn't always the newest one. Sometimes an old idea becomes the perfect solution for the future. The farther humanity travels into space, the harsher the environment becomes. Extreme cold, endless darkness, massive distances where repairs are impossible. And yet, one of the machines helping humans survive out there was invented before airplanes even existed. A quiet engine from the 1800s, now helping power the future of space exploration. And maybe the strangest part of all, the future of space travel may depend on one of the oldest engines ever created. And if you enjoyed learning how a 200-year-old engine is helping power the future of space exploration, make sure to like the video, subscribe for more engineering and science content, and let me know in the comments what technology should we explore next.